Okay, thank you. Good evening, everyone. Today we all are assembled over here for the fifth day of IFSFS 2020. I, Vidya Kipi, host of the evening, on behalf of entire IEEE Kerala, would like to welcome you all to the fifth day of IFSFS 2020. Today we are having two tracks of technical workshop. So the first track is on the topic Introduction to Robo-Sanitizer by Engineer Anish MS. Without any further delay, first of all, I would like to welcome Mr. Anton Verghese for the welcome speech. So, please.
A very good evening to one and all. It gives me immense pleasure to witness so many attendees for this technical workshop, a series of initiatives taken up by IEEE's Young Professionals Kerala. Moreover, I feel proud to be a part of the same. I welcome our speaker, Mr. Anish MS. He is pursuing his master's degree in embedded systems at Saarland University, Germany. He is also serving as the Global Relations Coordinator of IEEE's Young Professionals Kerala. He has been serving as robotics workshop facilitator since 2018. I welcome you, sir, to this technical workshop. I hope and believe that you would be able to train our students quite incredibly. Thank you so much for being a part of us today. I welcome the whole team of IEEE's YP Kerala. I genuinely believe the intensity of passion that each and every member of the team has to make a real difference, to prove it to the rising youth how volunteering is not just a formality, but something that stays with you eternally. I'm extremely happy to have such enthusiastic team members. I welcome the IFSFS team as they have invested their heart and soul to organize all the events. Next up, I welcome all the vibrant student ambassadors of IEEE's YP Kerala as well as IFSFS 20. The energy of these young volunteers is indeed an inspiration to all. Last but not the least, I welcome all our attendees. Without your involvement and participation, no event could be successful, and I'm glad you all are a part of this today. Without further ado, let's start the workshop. I hope you all will have an amazing learning today. Over to you, Anissa.
Yeah, thank you, Anton. Thank you for the introduction. So I hope I'm audible to you. Sorry for the I would like to call it not a workshop. To be frank, it will be like some webinar only, because we don't have any hands-on experience during this session. But I have provided almost all the materials, the codes, softwares, everything in a Google Drive. After this meeting, I can share you with the Google Drive, and you can try it yourselves. So in this webinar, we'll be studying how to make a robo sanitizer. Most of the student branches in Kerala section has done the robo sanitizer challenge. So this will be a short introduction about robo sanitizer challenge and how to make one yourselves. Okay, so in order to cut short the bandwidth, I'll be turning off my video and I'll be sharing my screen now. Can anyone please confirm whether the screen is visible or not?
Yes, sir, it is visible.
Yeah, is it in full screen, right? So, yeah, thank you for confirming. So, you all are part of the IFSFS program, and this is the webinar on introduction to robo sanitizer. So, I would like to start with an introduction COVID-19. Okay, we all are facing the COVID-19 pandemic, and we all are in a particular scenario, and that is not quite familiar for us. So I'm not getting into the details of this pandemic and all, but the things which we have to follow, the four essential things to prevent COVID-19 is using hand sanitizer, using mask, using soap and hand wash, and using tissue while sneezing and all. Okay, follow these 4 things and follow social distancing. You'll have a very little chance of getting affected by COVID-19. So these rules has to be strictly followed while in public, and we are mainly focusing on these 2 items: alcohol-based hand sanitizer and soaps and hand wash. Okay, we are going to automate these things because continuous hand usage of this sanitizer and hand washes can be reduced when it is automated. We need not to use our hands to open and close these lids. We can automate these things in order to avoid the continuous interaction with it. So, and this was a challenge introduced by PES Young Professionals Kerala during the start of this COVID-19 pandemic, and it was a challenge, and almost 20-25 colleges around the country and some outside the country has taken this challenge, and many colleges has participated in the challenge. They had created robo sanitizer by their own, and they had implemented it in public. So there will be a lot of people from outside Kerala and outside India in this webinar too, and you can also try this thing, and you can be a part of robo sanitizer challenge. So I'll just show some introduction video. These are the videos which was created as part of robo sanitizer challenge. Yeah, that was a short intro video just to give an idea what we are going to make after this webinar. Okay, so after this webinar, you'll be able to make such a thing by your own. So these are the main components required for making this this robo sanitizer. We need an Arduino Uno or Arduino Nano that will act as a a microcontroller, a brain of the system. So that these things are optional. Okay, you can either use a servo motor so that you can build the robo scientist which I showed the first video. Okay, otherwise you can use a mini water pump which will be much more easier to make. You can use ultrasonic sensors or IR sensors. I'll explain the usage of ultrasonic sensors and IR sensors. A 9-volt battery, a switch, and single strand copper wires. These are the common things which you can find from any electronic shops. So just this was a short intro about the components. This is the Arduino Nano which I use for making such a thing. This is the this servo motor. This is the ultrasonic sensor, a small switch, a small piece board, and a 9-volt battery, and what a sanitizer bottle. This is not a sanitizer bottle, it's a hand wash bottle. You can either use a hand wash bottle or sanitizer bottle. So these are the basic components which we need to create robo sanitizer. So first of all, I would like to explain each and every parts. Okay, I will explain the usage, how to use, what are the purpose, and the specifications of each and every parts of this project. And then I'll show the circuit diagram. I'll explain the connection of each and every, like how to connect a servo motor, how to connect an IR sensor, how to connect ultrasonic sensor, and how to test all those things. And then we'll go on to the complete circuit diagram, how to wire up the entire circuit. I'll provide you a circuit diagram and a fixing drawing of this thing, and you can verify all these things in the Google Drive also. Okay, and I will also try to explain this code. I don't know how clearly you will understand the coding, but I'll try to make it very simple and explain to you. So let's begin. Let's begin with the session. So the first thing which we need, that is the main thing which we need, is Arduino Uno, okay, or any microcontroller. We don't have any alternative for microcontroller, so we have to. It's a necessary part of our project. Okay, even if you don't have a servo model, we can make a robo sensor. Even if you don't have an ultrasonic sensor or an IR sensor, we can make a robo sensor. But if you don't have this microcontroller, then you have to go deep into the electronics by using MOSFETs or the drivers for the MOSFET, like transistors, everything to create such a circuit. So it will be quite easier if you have a microcontroller with you. So, and in this project, we'll be using Arduino Nano, which I use. You can either use Arduino Uno or Arduino Nano. Okay, this is the most common development board which is available in the market. It will cost around like 200 or 300 rupees. And these are the features of Arduino Uno. Okay, in between, if you have any doubts, just raise your hands, or just unmute and tell, or just post it on the comment section. I can clear it towards the end of this webinar. Okay. So these are the features of Arduino. We have a microcontroller Atmega 328 created by the company Atmel, and the operating voltage is 5 volt. Input recommended voltage is 7 to 12 volt. And input voltage limit is 6 to 20 volts. So creating a project, be careful that you should not give a voltage which is beyond 20 volts, because beyond 20 volts cannot be handled by the microcontroller and it will get damaged. So we have input output pins, 14 input output pins, out of which 6 are PWM, 12 are digital pins, and 6 analog pins. These digital input output pins are used for controlling our motors and all. And these analog pins are these are analog input pins. Okay, analog input pins are mainly used to take sensor values. Okay, in this project we are using a sensor, ultrasonic sensor or IR sensor, and these sensors has to be connected to the analog input pins for getting the input values. And the DC operating current is 40 milliamps, and we have another port that is 3.3 volt pin, and it will be 50 milliamps. All these things are not required. This is just the electronics of the microcontroller. It has a flash memory of 32 KB, SRAM is 2 KB, EEPROM is 1 KB, clock speed is 15 megahertz. That is the communication between the chip and all will be 16 megahertz. Okay, all these things are not necessary, just for your information about the board which we are going to use. Okay, this is the mini version of a smaller version of Arduino Uno, that is Arduino Nano. Okay, it is very compact, and it is also readily available, and it is much more cheaper than Arduino Uno, and it will serve each and every purpose done by Arduino Uno. Okay, so you can use Arduino Nano as an alternative for Arduino Uno. And yeah, these are the features of Arduino Nano. Almost all those things are same. Only the main difference comes in the weight. Okay, because it is just 7 grams, so you can easily connect and easily place this thing wherever you want. And the software which we are going to use is Arduino CC. That is a software designed for Arduino and other microcontroller boards, not only for Arduino, but also we can use it for other microcontroller boards, but mainly it is for Arduino. Okay, this is a software interface. I think I had included the link for downloading the software also in the Google Drive. Towards the end of this webinar, I will share you the Google Drive link. Okay. Yeah. Okay, I will explain the coding thing. I will just basically explain what are things are there in this software. Okay, we have a void setup. Okay, this is the board. I don't know whether it's visible to you. Is it clear for you? Okay, yeah. So we have a void setup and a void loop. Okay, whatever things which need to be constant will be displayed here. Okay, in the void setup. Okay, and whatever things which need to be continuously changing or continuously analyzed will be written in the void loop. That is the very basic thing about the software. So whatever things which you need to be fixed in the entire project need to be put in the void setup area, because the pin mode 10 output, this is just a basic program for blinking an LED. The pin mode 10 comma output is stating that the 10th digital pin is set in the output mode. So if you connect an LED to LED is positive to the 10th pin and LED is negative or the ground to the ground of Arduino Uno, um, then okay, I'll do one more thing. I'll just show the okay what our connections are available in Arduino. Okay, these are the analog pins A0 to A5, the 6 analog pins. These are the digital pins 0 to 12. 0 to 12 is mainly used, and 13 is a default light. Okay, you can connect, you can also connect, but mainly this 13th pin will be connected to this light. Okay, this is a SMA LED, and we have three grounds. Okay, this is first ground, this is the second ground, and the third ground. Okay, whenever you're trying to connect something, you can connect your positives in this digital pins and negative in the ground. Okay, so the circuit will be completed. And then we have the 5 volt. This is the 5 volt output pin. Okay, this is a 5 volt output pin, and this is the 3.3 volt output pin. Okay, if you want power something from this circuit board or this Arduino board, like if you're connecting a sensor, then the sensor need have a VCC and a ground. For this VCC, you have to provide a 5 volt supply. Okay, just to power up that particular sensor. For that, you will need a 5 volt connection. So you need not to take separate battery. For that, you can directly take this 5 volt from this Arduino board itself. Okay. So this is the Atmega 328 chip, and this is the input output connection, and that can be connected to your PC, and this is the power. Okay, you can either connect a DC jack, DC 5 to 12 volts recommended. You can either connect a DC jack, or else you can observe a pin here, V in. Okay, if you connect a 5 volt a battery between this V in and this ground. Okay, you can connect a battery in between this 5 volt and ground. Then also you need not use this thing. The board will be powered. Okay, so these are the different options. Or else you can directly use this. Okay, you can use this cable to connect to the PC. In that case also the board will be powered. So you have three options for powering this board. You can either connect to the PC, or either use the DC port, or you can use the V in and ground. Okay, these are the basic. Okay, there is a reset button also. Okay, you can use the reset button. Whenever you load a program and you need to reset this thing, you just press this reset button so that the default program in an Arduino, that is the Blink program, will be restored to this chip. Okay. These are the basic things regarding the board. We were explaining this thing. So yeah. Okay, so void setup, I had written pin mode 10 output. Okay, pin mode 10 output means I am setting this 10th pin as an output port. Okay, 10th pin as an output port, because we have the 0 to 13 as input IO pins, input output pins. So you can either take input or you can provide output. Okay, so I am setting that the pin mode 10. Okay, 10th pin as an output port, and that is the thing which I need to fix. Okay, this thing should not change during my execution of the program, or during the working of the Arduino. So this thing I had fixed, and inside the void loop I need to change. I need the things which has to be altered. Okay, like digital write 10 high means providing a 5 volt to the 10th pin. Okay, if you have connected an LED to the 10th port and ground, then if you I write this code digital write 10 high, then when this line is executed, okay, when this line of the code is executed, then a 5 volt will be sent to the 10th port of this Arduino, and correspondingly the LED will glow because the 5 volt is enough for glowing an LED. Okay, next I had written that delay 1000. This 1000 means 1000 milliseconds. Okay, 1000 milliseconds or 1 second. So delay 1000 means this code will be this first line digital write 10 high will be executed, and then it will wait for like 1000 milliseconds or will wait for 1 second and then execute the next line, that is digital write 10 low. Okay, then the board understood that it has to withdraw the 5 volt which it had provided to the 10th port. So a zero will be digital zero will be sent to the 10th, and thus the 5 volt will be withdrawn and there will be 0 volts. So the LED will turn off. Okay, and it will wait for 1 second, and this thing will be continuously running. That's why it is written inside this void loop. This thing will be continuously running. So if you do this program and you can see this. Okay, this tick mark is the compile and this thing is the upload. Okay, so if you compile and then upload this thing to the board, then if you connect a LED to the 10th pin and ground, it will be continuously glowing. Like it will be turned on for 1 second and turned off for 1 second. So that is the basic thing what we are going to do. That is a very basic thing about Arduino and about its software. Okay, like this only we are going to code this entire concept. Is it clear till now? I hope it is clear till now. So we can move on to the sensors. Okay, which are sensors which we are going to use during the project. This thing is the one of the famous sensors, that is ultrasonic sensors that work on the principle how bats detect their prey, they detect the objects around it. Okay, we have this is the ultrasonic sensor, the front view, and it have two main eyes. Okay, you can call this as the eyes of this ultrasonic sensor. One is the transmitter, other is the receiver. Okay, this transmitter will be transmitting an ultrasonic wave. Okay, ultrasonic wave which cannot it's just a sound wave. Okay, this ultrasonic wave will be transmitted and it will hit at a particular object and it will return back. Okay, this thing is mainly used for detecting our hand, because our robot hand is when we move our hand towards the this lid of this sanitizer bottle, it had to operate. Okay, so is there should be some system to understand that our hand is coming towards it. So this ultrasonic sensor will be sensing the movement of our hand. So our hand will act as the object. Okay, object or the obstacle in the path of this ultrasonic sensor. So this ultrasonic sensor will be transmitting an ultrasonic sound, and when we put our hand here, okay, this is our hand. So this waves will hit our hand, it will reflect back to the receiver. Okay, it will be reflect back to the receiver and the receiver will receive this. Okay, so this distance, okay, we need to calculate this distance. For that we will be using the time delay technique. Okay, so the transmitter transmit the ultrasonic sound and the receiver receives it. There will be a time delay between the transmission and the reception. Okay, if the object is so far, the object is here, then it will take much more time to reach here and reflect back. Or the object is so close, it will take less time to reflect. Okay, so the key thing is that we need to calculate the time delay between the transmission and reception, and we will convert that to distance. So that we can easily sense that the distance is getting closer or the object is getting closer, so it has to operate. That is the basic key thing in while using the ultrasonic sensor. Okay, so this is a transmitter, this is a receiver, and it has got 4 pins, that is a VCC, trigger, echo, and ground. Okay, So this 5 volt will be connected to the 5 volt of Ordno, ground will be connected to the ground GND of Ordno, and it will be connected to the 5 volt of Ordno. And we have the signal and echo pins. It will be connected to 2 other pins of the Ordno. I will show the detailed connection diagram. And this, when the trigger is, when we give a signal to the trigger, then it will be triggered, and this echo will be receiving that signal. Okay, the reflected signal. That is a basic working principle of ultrasonic sensor, and its name is HCSR04. Okay, you can search for ultrasonic sensor in eBay, Amazon, and all, or you can search for HCSR04. And an alternative, it will be much more costlier, it will be much more bigger, it will require much more power, and it has 2 pins, okay, trigger and echo. But it will be very precise, it will precisely detect your hand. But this is a cheaper alternative for ultrasonic sensor. You can use IR sensor. IR sensor also works in somewhat similar principle. Okay, it also has an output. Okay, it will be the signal and a ground and VCC. It does not have a trigger or something. It will just have an output, and it will sense the output, sense the motion, and it will be sending signals through this output pin. Okay, you can connect this VCC to the 5 volt of Ordno and this to the ground. Okay, I will explain the working. Your sensors. It will also have a transmitter LED and a receiver LED. The difference is that here we are not transmitting ultrasonic sound. Here we will be transmitting light. Okay, infrared lights. So this IR LED will be emitting an infrared light, and it will hit on an object. Okay, and it will get reflected back. This light will get reflected back, and it will be received by this receiver. So similar principle of ultrasonic sensor, but the thing is that there the sound is being transmitted, here the light is being transmitted. Okay, and while the object is coming closer, a particular value, okay, it is coming closer. So the distance corresponding to the distance, a particular value will be, an analog value will be sent through this output pin. And like, if the distance is coming closer, let's imagine that the value was initially 1000. Okay, initially it was 1000. So when it comes closer, it changes to 800, then 300, and when it is 200, it is too close that our robust analyzer should operate. So we understood that when the value is 200, our robust analyzer should operate. So that's how we are going to program this thing. So we will put a condition that if the value received from this output pin is 200 or less than 200, then the servo motor has to be operated. Okay, that is a simple algorithm of the program, and the program will be written in a different language. But the simple algorithm is that if the output value received from the sensor is less than 200, then the ultrasound, then the servo motor has to operate, and correspondingly the sanitizer liquid should be dispensed. Okay, so these are the features of the ultrasonic sensor and infrared sensors. You can just go through this. I will share this PPT, and this is working, which I just explained. The IR emitter will be emitting the infrared rays. The object will reflect it back, and it will be received. Okay. Yeah, there is a note here. Black surface absorbs light naturally, so it will not reflect much light to IR receiver. This concept is used in line follower. Okay, that IR sensor can also be used as a line follower. That's represented here, because when we shed some light to the black surface, it will not try to reflect this thing. It will try to absorb this thing. Okay, so if you're using an ultrasonic sensor as a line follower, then you can use this principle. Okay, the next important thing is the servo motor. Okay, so servo motor is like a simple motor, but it is similar to the geared motor which we use in toy cars. But the difference is that it has high precision. Okay, it has high precision, and it is mainly made to rotate in angles. Okay, if you can rotate it from 0 to 190 degree, and from 180 to 360 degree, and so on. Okay, like if you provide a particular angle, like go to 95 degree, then this thing will rotate exactly 95 degrees. So that is how servos are used, and we are using servo motors here for bringing down that pressure lid of this sanitizer bottle. Okay, so it also has three different wires. One is the signal wire that is normally in orange in color. One is brown that is negative, and the red which is positive. This positive can be connected to the 5 volt, which I showed in the Arduino, and this brown can be connected to the ground, and the signal can be connected to some other pin in the Arduino board. Okay, for the control. So this is the simple internal diagram of a servo motor. It will be having an H bridge. Okay, H bridge will be precisely controlling the potential. Okay, this potentiometer. Okay, this potentiometer will, you know the working of a potentiometer, right? If you rotate a potentiometer, then the corresponding resistance will be changing. Okay, so we are using the reverse principle here. Okay, so in order to adjust this thing, the angle, we will be using, we will be changing the resistance. Okay, changing the resistance through this wires, and corresponding the potentiometer will rotate. And we are using a DC motor for this rotation of this thing. Okay, this will be the control, and you will be connecting the wires. Okay, you will be connecting the wires, or you can attach the lid to this plastic thing. Okay, this is the gear, and this is the DC motor, and this is the H bridge which is used to control this thing. Okay, it has different switches, like MOSFETs will be used for switching between switching the direction and all. Like you know the basic working of a motor, right? Suppose this is a motor, and it has a positive. Okay, it has a positive and it has a negative thing, negative ports. Okay, if I connect the battery like this, okay, I'm connecting the positive to the positive and negative negative, it will rotate in one direction. And if I alter the connection, like if I change the connection from negative is connected to positive and positive is connected to negative of the battery, then it will rotate in the opposite direction. Okay, that is the simple working of a DC motor. So how we can change the direction. So in our case, we will not be manually switching between this positive and negative. We will be using the programs, and the program will correspondingly send the signals to this H bridge, and this H bridge will be switching the positive and negative of this DC motor. So that is the basic working of a servo motor, and these are the specifications of a servo motor and how to configure an Arduino. Okay, after connecting your Arduino, after taking your Arduino, you have to connect it to your PC via the USB port, and you have to go to these tools. Okay, I hope it's visible to you. Yeah, you have to go to these tools, and from that you have to select the board. Okay, which board you're using. You can take Arduino Uno, or you can take Arduino Nano, Arduino Mega, Arduino Lilypad, anything. Okay, any which Arduino board you can select based on the which board you are using. If you are using an Arduino Uno, then you have to select this board as Arduino Uno. Then you have to select a port. Okay, as soon as the not activated, it's blur, right? But as soon as you connect the Arduino board, this port will be activated, and you will show that the Arduino is in the 19th port or 18th port or the 7th port. Okay, you have to click on that. That's done. So the physical connection is done. Now you can program and click on upload to upload the programs to the Arduino board. That is the simple configuration of the Arduino software and the board. So now we can move on the connections. Okay, different connection diagrams of the sensors. So this is the connection diagram of ultrasonic sensor. The VCC is connected to 5 volt, ground is connected to the ground, and this trigger and echo is connected to the analog pins. You can also connect it to the digital pins. Okay, this is the connection diagram, and like I'll just explain the program. I have defined this trigger pin is analog pin A1 and the echo pin is A2. This is the first definition which I gave to the Arduino, stating that these are the default conditions. Okay. Then I written that maximum distance is 200, and I had initialized a variable named distance, and I had put a value 100 there. Okay, and this is the default sensor function stating that new ping, sonar, trigger pin, echo pin, and maximum distance. That is, we are initializing these values, okay, to this library. So this inside this library, everything will be stored. So whenever you give these values to this library, the library will automatically do the mathematics and all. Okay. So inside this serial void setup, I had written serial.begin. This serial.begin is just to monitor the serial monitor. Okay, you can see this thing. Okay, a magnifying glass symbol. Okay, if you click on the magnifying glass symbol, you can see the values coming from the sensors in the serial monitor, a monitor named serial monitor. Okay, in order to establish the communication between the Arduino board and serial monitor, we are using the serial.begin 9600 command. Okay, then inside the void loop, I had defined this distance is equal to read ping. This is a function. Okay, and it will be written down here, and the serial println distance that after executing this command, the distance will be printed to this serial monitor, and you can easily measure the distance. And this is the conversion. This is the conversion where this value, this sensor value is being converted to the centimeter. Okay, I'll share you this presentation, and all the codes will be saved in that thing, so you can straight away try using this thing. So this is the connection of the servo motor. It is somewhat similar to that of our sensors, only the 5V will be connected to the 5V, ground will be connected to the ground, and the sensor will be connected to some of the digital pins. Okay, digital input output pins. Okay, and recommended it should be connected to these pins. Okay, these are the PWM pins with the small sine wheel put on it, so that we can give you need not to give 0, 1, 2, 3 values. You can give like 4.5 volt, like that. Okay, you can give analog values instead of digital values. That is the advantages of using this 11, 10, 9, 6, 5, 3 pins. Okay, they are PWM pins. So this is a connection diagram of server, and you can use this program for testing the servo motor. I'm not going to explain each and every program. It will be much more boring to you. So like this is the program for servo motor. I had initialized the servo motor, attached the servo to this 10th pin and 9th pin, and I was using 2 servos for configuration. So that's why there is servo 1 and servo 2. Then I had written this code, this POS1 and POS positions. Okay, these are the initial positions, and this program is to rotate this servo from 0 to 90 and from 90 to 0. That is, the servo will, after executing this program, the servo will be simply rotating from 0 to 90 and from 90 to 0. Okay, just quite a simple program. You can just go through this program and understand these are just 4 different loops and all. So if you have some basics in C++, C or Python or anything, no, not Python, but C or C++, you will be knowing this conditions, loops and all. So that is the program for testing the servo motor. So you make this connection, execute this connection, and upload this program to the servo, this Arduino board, and then wait for some time. Then the servo will start rotating like from 0 to 90, from 90 to 0, 0 to 90, 90 to 0. Okay. So that is if that is going right, then the servo is working properly. And this is the connection diagram of the robo sanitizer. Are we out of time? Yeah, no, we are on time. Okay, so this is the connection of robo sanitizer. Like this, this is the Arduino Uno board. I have connected the ultrasonic sensor, the servo motor, and then I have connected a switch and a battery. Okay, now I am not using this DC ports. Okay, I am not using the DC port. I am not using the PC, the connection to the PC. I am using this V in and ground. Okay, this V in is directly connected to the switch and to the positive of a 9-volt battery, and the negative is connected to the common ground. This thing is the common ground. Okay. So when I switch on this, turn on this switch, the Arduino will be powered. Correspondingly, the 5 volt will be sent to this ultrasonic sensor. So the ultrasonic sensor will turn on. The servo motor will also turn on. Okay. Now this is the entire program of this robo sanitizer. So these are the different libraries. Okay, hash include servo.h, hash include newping.h. Everything is the libraries for servo motor. Newping is the library for ultrasonic sensor. And I had combined the each and every program which we had written to make this entire program. Okay, and defined the A1 and A2 as the trigger and echo pins, and defined the distance, variable distance, and the command to the library, and attached the servo. Okay, attached to the 9th pin, and distance is equal to read pin. I started reading the distance. Okay, and here is the key area. Okay, serial.println distance. The distance will be displayed in the serial monitor, and you can lively monitor it in your computer. And if the distance is less than 50, okay, if the distance is less than 50 means, okay, my hand has just moved near to our robo sanitizer. Okay, my hand has just moved near to this robo sanitizer, and this event has been detected by the ultrasonic sensor, and it has detected that the value will be decreased, and the distance is we have defined that the maximum distance should be 200. Okay, 200 centimeter. Okay, and when the distance is less than 50 centimeter, it states that my hand has just moved moved near to the robo sanitizer, and then these things should happen. This is an if loop, and if the distance goes less than 50, then if the ultrasonic sensor detects the distance to be less than 50, then I will execute this for loop, so that the servo will be rotated from like 90 to 180 at an interval of 30. Okay, it will like go from 90 then to like 90 plus 30 120, then from 120 plus 30 150, then 150 plus 30 180. Okay, it will be like step movements, and it will be smoothly moving, because we had provided the delay of just 100 milliseconds. Okay, so between this thing, the delay will be 100 milliseconds. So it will be smoothly moving, and it will wait for some time, and then it will return. Okay, from 180 to 90. Okay, it will be returning from 180 to 90, and it will take a delay. So this is the basic thing. So whenever our hand moves towards this thing, when the hand reaches the perfect position, the servo will be rotating, and correspondingly the pressure pump will be actuated, and correspondingly the sanitizer liquid will come out of the board. Okay, this is the function which we used here, the read ping function, and I have written the function outside. Okay, this is the robo sanitizer program. I had also included this program in the Google Drive. So this is the working model which I made. Okay, you can make your own versions of it. So this is my ultrasonic sensor. So I just have to move my hand towards this. Okay, I'll move my hand towards this. So when my hand comes above this ultrasonic sensor, this will act as an obstacle. This hand will act as an obstacle, and this ultrasonic sensor will sense that a hand has just moved above the sensor. Okay, the value which will be sent to this is the circuit, so this Arduino board. Okay, this value will be sent from this ultrasonic sensor to this Arduino board, and Arduino will understand that okay, the hand has just moved in, the distance has gone less than 50. So this is a servo motor, and this servo will operate. Okay, you can see I had attached a copper wire. Okay, copper wire to the end of this tip of servo motor, and it has been fixed to the other end. Okay, now when the hand moves, this sensor, okay, this servo motor will rotate, and it will rotate in this direction. Okay, it will move from the top to the bottom. Once again, yeah, it will be rotating in this direction, and this will be moving down, and correspondingly this copper wire will also move down, and thus the sanitizer liquid inside this thing will be moving out. Okay, this is the basic working model. Now I will show once again the video which I showed in the starting so that you will now understand how this thing works. Yeah. See, when here they are using this ultrasonic infrared sensor, and when the hand moves towards, see, when the hand moves towards this sensor, it detects and correspondingly the servo motor operates, and the sanitizer liquid has been dispensed from the sensor, the bottle. Okay, that is the basic working. So that's all about. Is the time? Yeah, we are 10 minutes ahead. I'll just show the working once again. This is the working of the thing which I made. See. See, when the hand just came above the ultrasonic sensor, the sensor detects that there is a hand above it. So it has to operate this servo motor. The servo motor just rotated and the cap was moved down. See, you can see the down movement of the cap, and the sanitizer liquid was dispensed from the bottle, and the servo motor automatically returned to this original position because we had written the program for rotating from 90 to 180 and from 180 to 90 back. Okay, see, yeah, so that is the basic working. So that's all from my part. Now if you have any doubts in any of the part during the webinar, you can ask me now. What are the industrial applications for robot sanitizer? Okay, I'll stop the sharing now and I'll get back to WebEx. Yeah, okay. What are the industrial applications of robo sanitizer? Okay, this is just an introduction to robo sanitizer. Okay, you can there are a lot of companies who is working on robo sanitizer. They can. This is just a prototype which we can use in our home as a hobby project or something. So if you're asking about the industrial applications, then um, like you can make a precise model by eliminating this sanitizer dispenser bottle, normal sanitizer dispenser bottle, and you can use a mini water pump. Okay, that was included during my components list. Okay, you can use a mini water pump, so it will precisely provide the amount of liquid dispensed from that and all, so that you can create a product dedicated as a robo sanitizer, and you can provide it to the market. Okay, so that you can make you can earn a living from that. So that is that can be considered as an opportunity for the entrepreneurs. Yeah. Other question, is there any limitations in robo sanitizer when we use Ordino? Is there any limitations in robo sanitizer when we use an Ordino? Yes. Yeah, there will be some limitations because you need to power this robo sanitizer by using a 9-volt battery, which I showed. Okay, so if it is powered by a 9-volt battery, when the battery power is gone, then everything will be done. Okay, and you can either use an adapter. So if you are using an adapter also, then when there is no power current is no current supply, then the sanitizer will not work. And other limitation is the cost. Okay, if you can create the circuit by using some MOSFETs, a driver for the MOSFET or a transistor, then it will be much more cheaper. Okay, it will be much more cheaper, but it will not be that precise. You will not get that precision. And if you use trying to make the circuit using transistors and MOSFETs, then you cannot use this ultrasonic sensor, because ultrasonic sensor mainly work designed for this microcontrollers like Arduino and all. So you cannot use this ultrasonic sensor for sensing the values. Okay, you can use infrared sensor. That too, you have to do many calibrations, and you have to be very precise to get a precise operation of the robot anti-sub. The advantage in using an Arduino is that you can, if you find that there is a defect, you can just simply change the code which you had uploaded to the Arduino, so that you can adjust the values. Okay, if you feel like that, okay, I have to rotate the servo motor a little more, then you can just simply write the code from rotating from 90 to 180. You can rotate from 90 to 270. Okay, then it will rotate much more. So all these things can be done while using an Arduino, but you cannot precisely control all these things while you are not using an Arduino. So that is the advantage, and the limitation is that it will be much more costly. So there is one more question. We can only make the sanitizer dispenser by using Arduino. Yeah, I didn't understand the question. Yeah, I think I had answered that question. You and no, you can also make the sanitizer dispenser without using Arduino by using these basic elements of electronics. Okay, what if a person don't know about programming and he or she want to make a dispenser? How can he or she make it? Okay, that also I can suggest that you can do this by using basic electronic circuits. Okay, because for using a transistor or a MOSFET, you don't need to know the programming, microcontroller, computer, everything. You don't need all those things. You just need the this transistor. A transistor, you know, the transistor can be used as a switch, so you can use that property of using transistor as a switch, and you need a gate circuit for triggering this thing. It can also be an electronic circuit. So for that case, you know, need not to use programming and all. But the thing is that you have to do a lot of calibrations for getting the precise point where the switching has to be done. You need to decide how much gate voltage should be given for switching on the transistor and all those things. So I think that answers the question. So if there is any other questions, you can ask now, or else we can wind up the session. So I'll do one thing. I'll share the Google Drive's link so that you can go to the drive and download all these PPT, circuit diagrams, programs, everything which I had given here. One second. Yeah. So I had posted the link to the attendees, so you can visit this link and get the documents and the circuit diagrams, pictures of the circuit diagram, the fritzing drawing, everything has been included in this drive. Okay. So I think we can wind up the session, right?
Yes, sir. So thank you so much for sharing your insight and experience over the topic. And now I would like to welcome Muralidharan for the vote of thanks.
Thank you, Vidya. So, as all good things come to an end in our lives, so is the first part of today's session. On behalf of IEEE PS5P Kerala, I take this opportunity to propose a vote of thanks to those who have contributed to this webinar on Introduction to Robo Sanitizer. At the outset, I thank our resource person, Engineer Anish and Hess. We are really enlightened with your knowledge and presence. Our heartfelt thanks to the attendees for the active participation. With these warm words and a kind message, we move on to the end of the first webinar of today's session. Thank you.
Thank you, Devi. So, guys, this was the end of our first track of the evening of the fifth day of IFSFS 2020. So, our next track will be a technical workshop on the topic of autonomous robots and application in COVID-19, which will be handling by Mr. Varghese K. Benny at 7 p.m. I request everyone to be here at 7 p.m. So, thank you, guys. Have a good day.
Thank you.
Okay, sure.
Okay, Devika, you may take.
A warm welcome to all of you. So today we have Sustain here in this webinar for the second session of the fifth day of the first ever virtual humanitarian summit, IEEE for Sustainable Future Summit 2020, organized by IEEE as Young Professionals, Kerala. I immensely welcome you all to witness this wonderful session. I, Devika Muralidharan, the moderator of the current session, welcome each and everyone present here for the fourth technical webinar of IFSFS 2020. I welcome all the guests who have accepted our invitation, the IFSFS team members, mentors, young professionals, and student members of IEEE PS5P Kerala. And last but not the least, I welcome all our attendees. Without your involvement and participation, this event could not be a huge success. And I'm glad you're all a part of us today. Now, without further delay, let me begin the technical webinar on autonomous robots and applications in COVID-19. The speaker for our today's webinar is an entrepreneur, a traveler, and a volunteer. He's a young and energetic individual with a demonstrated history of working in consumer electronics industry. He is well skilled in Raspberry Pi, event management, Arduino, ethical hacking, etc. He is currently the founder and the chief executive officer of Rabbit Square and was an electronic design automation engineer in G-Code Innovation. He is a strong business development professional with a Bachelor of Technology focused in electronics and communication engineering. This all describes a personality, none other than the speaker of today's session, Mr. Varghese K. Benny. Sir, the session is all yours. Hello? Hello, sir?
So, is that audible? So, you received the so you may take over from now. Uh, so I
Sir,
think so
actually,
you're muted. So actually you're
you're
muted.
no, sir, currently you're in mute. Could you please unmute that?
Okay, I think I will try to unmute you. How are you audible?
Yeah, good. So, hi all. So, good evening. Okay, so I couldn't hear the introduction, what is given on me. So, without wasting much of our time, we'll directly go into our topic, that is robots and COVID-19. And this will be an interactive session, and definitely you people can ask me doubts in between. Okay, so, and if I ask you any questions, do respond to me. Okay, is that clear? Can anyone respond?
Yes, sir.
Yes, sir, sure.
Hello. Yeah. So we shall begin the session. Yeah, good, great. So I need students to be responsive. Okay, and let me share my content. So coordinators, just I'm facing some difficulties in uh, sharing my screen. Can you just rectify that?
Okay, so may I know what's happening?
Yeah, okay, fine. Okay, so once again back. So today we'll be seeing robots and applications in COVID-19. As you can know, the world is actually on a full stop. Really, we don't know what to do. And this topic seems to be very interesting to me when this IEEE guys just approached me, because this is something, being engineers, we can do so many things in this issue. So that is why I came here, and I told them I will take this session for you people. So without wasting our time, we'll start off. So I don't know whether you know me or not. I'm Verghese Benny and the founder of CEO of Rabbit Square LLP. Okay. And for this, I don't want any introduction. What is COVID-19? And from the last, what, March onwards, we are hearing this name, COVID-19, COVID-19 everywhere. And there is, we don't know what to do. The world is really like, in a situation where we don't know actually how to handle this issue. Unless this being engineers, so, how- so what is your opinion or your suggestion? Can I hear that from your side, at least any one of you? Being engineers, what can be done? Anyone? Guys? Okay. So there are many things. Some of them were like automatic hand sanitizers. Okay, it was quite interesting. Like even kids were like making and sharing in this. And next one was robots. Robots in treating COVID-19 patients in isolation wards. And anything else, you know? So there are n number of possibilities being engineers we can do. And today we'll be focusing on robotics or robots and COVID-19. Okay. Okay. Robot. I, got infected. So only thing at that day onwards, even I was thinking, how can we do to this treat this patient this because there is no other special treatment or something in for this disease. Only thing is symptomatic treatment. Only give good food, like medicine, adequate medicine, all those things. Okay, so in that case, there comes the application of our robots. The ultimate thing is remote control. Without going to the infected patient, how can we provide the medicine or what food items, water, all those things can be done in a COVID-19 ward or isolation ward. Okay, and I'll show you that this is a picture of a basic robot which is built. Uh, it was used in an isolation ward to provide the medicine and you can see
Sir, you're still in mute.
my session is lost.
Yeah,
I
yeah.
can't share my screen.
Now you will be able to share it again.
Can you please try it once more? I think now it's good.
Like I didn't hear.
Could you try once more to share?
Please try sharing it once more. I was
I didn't hear what you told. Full of disturbance.
Hello, sir.
Yeah,
Am I audible? Could you try
lot of
sharing it once
noise.
more?
Yeah, now I can hear it.
Could you try sharing it once more?
Yeah, yes. I can't share now. That option is like it's not there. I'm not the presenter, I think.
Yeah, you are the presenter. I think there is some issue. Let me just.
You are the presenter, sir.
There is some network issue because even I took like introduction, but I couldn't hear.
Okay, so 1 minute. So may I please try once again?
Hello.
Yes, sir. It's audible now.
Okay, even your sound also it's not audible to me perfectly. I think there's some network issues. Okay, good. So can you present that?
Rush.
Yeah, I think he's downloading the video. Rashid, just open it with the Google Slides. It will be more easy.
Yeah, it's
Rashid, could you change the slide?
sorry, it's sixth slide. Okay. Yes, sixth slide.
Hello, is it okay now?
Yeah, yes. Yeah, it's
Hello?
visible. Yeah, it's visible, Rashid.
Yeah, okay. Fine.
Is it okay for you? Hello, sir.
Is it okay?
I think he's facing some network issue.
So are we in the main session? Just tell me when to start, okay?
So we are ready to start.
We can start
Okay,
now.
good. So sorry all, we had some technical difficulties. So what I was telling is that this was a robot made in Kannur, I think, and it's named as Nightingale 19 and for helping nurses. Okay, as you can see, there is a water bottle, some medicines over there, and there's an IP camera on the top so that the patients can interact with the doctor or the medical staff directly. And this is simply controlled by radio signals. Okay, so by the end of the session, you are going to at least you're going to understand the idea of basic how to build a simple robot like this. Okay, so can we move on to the next slide? So next slide, please. Rashid, next
Rashid?
slide. Can you just
Yeah, it's visible, right? I think it's visible, right?
yeah? Can you just change the slide? Can you
Yeah,
just
sure.
change the slide? Yeah.
Yeah. Is it visible now?
We are currently in that
No.
same slide.
Hello?
Yeah, it's okay now.
Okay. Okay.
Yeah.
Now, yeah, it's okay now. So in this picture, you can see 4 different robots, and the first one on the top left and top right, both are built in Kerala, and bottom right one also. That is one that was from Asimo Robotics, I think, and Startup Mission. All those things you can see that delivering. There is hand sanitizers, some cloth, and all those things. Okay, so the working behind this type of robots is very simple because these are wheeled robots. Unlike other robots like humanoid robots, these wheeled robots are very easy to make, or the working principle is very simple if you understand the concepts. Okay, and next slide. So the big question, how to control these wheels? Okay, so how do we control the movement of these robots? Okay, as I have told, there are 2 types of robots. One is biped robots or humanoid robots, and the other category is wheeled robots. So today we'll be seeing how to make or how to control the movement of wheeled robots. So we know that in order to control a wheel, definitely we need a motor. Okay, so we shall see different types of DC motor in the next slide. Next slide. Okay, the first one, these type of motors you may have come across your just before. Yeah. So the first one is a yellow one. It's called a BO motor. The second one, it's a DC motor, DC gear motor, and the last one is it's called wiper motor, which is being used in vehicles wiper. Okay, if you have this wiper motor, we can make a robot similar to what I have shown in before. like 19 to 19 that was made in Kanno. If you got a pair of wiper motor, definitely you can control this. In order to make a prototype of these things, you can use a BO motor or a gear motor. Only thing why we use these wiper motors is that we can have more load on that our robot. Okay, at least a person. If I need to make a wheelchair, okay, automatic wheelchair, we can deploy this wiper motors. And how to control these motors is another question. Okay, and anyway, we need a minimum pair of 2 motors and a caster wheel. Caster wheel is nothing but a free wheel. So if you take the case of an auto rickshaw, the drive comes only in the back. Okay, and the third wheel is just a free wheel. Okay, similar concept we can adopt here. We need minimum a pair of motor or 2 motors to control the movement of these robots. Okay, and can I just move to the next slide, please? Okay, so in order to control these motors, we need motor drivers. So why do we need these motor drivers? For that, if I give you an example, so consider one single motor at a time. Okay, if I need to control the motor in the clockwise direction, okay, if I need to rotate the motor in clockwise direction, suppose I connect the polarity in one way. If I need to change or reverse the direction of motor in anti-clockwise direction, what shall I do? Just reverse the polarity. Okay, in the case of a robot, we need a minimum of 2 motors, and the 2 motors should rotate both the direction, that is anti-clockwise and clockwise simultaneously. Okay, if I need to go forward, if one motor is in for anti-clockwise and other one is in anti-clockwise, it will not work. Both the motors have to go in forward direction, and in the same case, if it is reverse, what is the case? Both the motors have to go in the anti-clockwise direction. And if I need my robot to turn left, what shall I do? I shall stop the right-sided motor, right-sided motor, and turn left motor on, so that I can turn my entire robot to the right side. Okay, and in order to turn my motor to the left side, I shall turn off my right side motor and rotate or give supply to the left-sided right-sided motor. So I shall say once more, if I need to turn my motor or entire robot to the right side, okay, I shall turn off my right-sided motor and give supply to the left side, so that it turns to the right side. Okay, on the other side, if I need to turn my entire robot to the left side, I shall turn off the left side motor and give supply to the right-sided motor. Okay, for this, we can't always change. I told you, in order to change the direction, we have to change the polarity. Okay, practically it is not possible. Whenever I need to change the direction, go and change the supply or reverse the supply manually, it is impossible. For that, we use motor drivers. So L293D, L298, and L9110S, all these are simple motor drivers that can be used for prototyping. Okay, in real cases, we have to make motor drivers with the help of some other components I shall tell you later on. Okay, so all these motor drivers works on the principle of edge bridge. Okay, so what is edge bridge? So just one click, Rashid, can you just give a click? Yeah, an edge bridge is an electronic circuit that switches the polarity of the voltage applied to the load. So it switches or changes the polarity. Okay, edge bridge. So what is the function of edge bridge? It changes the or reverse the polarity of the electronic or motor without changing any physical connection. Okay, these circuits you can see are often used in robotics and other applications to allow DC motors to run forward or backward. Okay, so that is the main idea of edge bridge. Without changing the physical connection, we can reverse the polarity so that we can control the motor in both the directions. Okay, and moving on to the next slide, Rashid. Next slide. Yeah. So this is the basic working of an H bridge. Okay, an H bridge consists of a pair of NPN and PN transistors. Okay, here you can see Q1 and Q3 are PNP transistors, and Q2 and Q4 are NPN transistors, and we have a DC motors in between. Okay, so in order to control the single motor, we may require two signals. Okay, that is Q1, Q2, Q3, Q4. Actually, there are four. So we are giving two signals at a time. So take the case of, one more thing. So in order to switch a PNP transistor, what should be given to the base of a transistor? It should be a negative pulse. And in order to turn on an NPN transistor, there should be a positive pulse to the base. Okay. So take the case, the working of H bridge is very simple. At a time, two transistor gets turned on. Okay. So initially take the case of Q1 and Q4. Okay, we are considering Q1 and Q1 and Q4. So in order to turn on Q1, we are giving a negative signal to the base of this transistor, so that from the VCC, this acts as a switch, and Q1 is in closed state, and it comes to the positive side of the motor. And negative, after a negative, what happened? The signal comes to the Q4. Q4, we are applying what? A positive signal. So Q1 is 0 and Q4 is 1. So when I give a high signal or 1 to Q4, this Q4 becomes closed. So the entire circuit gets completed. So from the VCC, the signal comes through Q1 and it reaches on the plus side and then reaches the negative and go to the Q4 and goes to the ground. So one path is completed with the help of Q1 and Q4. If Q1 is 0 and Q4 is 1. Okay, the signal what we are giving to the Q1 and Q4 is 0 and 1. Take the other case, consider Q2 and Q3. Okay, so if Q2 is, what should come to the Q2? Q2 is 1 and Q3 is 0. See that case? When Q3 is 0, you can see VCC. From VCC, the signal comes to Q3. The transistor act as a closed switch, and from VCC you can see the signal comes to the negative side. Okay, that is the polarity of the motor is reversed, and it comes to Q2. Q2 is also in closed state, and it goes to the ground. So without changing the physical connection, we can change or control the polarity of the motor using an H bridge. I know some of you have some doubts. I shall show you one other figure. So this is something based on transistor or something. So those who know transistor, they may understand. For others, we shall see the next slide. Next slide, please. Okay, so this is a simple animation where you can understand the concept very clear. So instead of transistors, I have changed into some switches. Okay, S1, S2, S3, S4. Okay, in the first case, switch S1 and S4. Okay, actually it is a transistor that comes. So we know that transistor can act as a switch. So I have replaced it as a switch. Okay, so you can see how the circuit path is completed. Okay, when S1 and S4 is closed. Okay, that is you have to understand that is both transistors Q1 and Q4, and Q1 should be Q1 is NPN, the other one is PNP. Therefore 0 1 comes S1 and S4, that is 0 1. When 0 1 comes, this circuit gets completed. On the other side, you can see on the right side, you can see that the polarity is reversed when the switches S3 and S4. That is, when S1 and S4, the case was 0, 1 for the transistors, and here the transistor supply is reversed to 1, 0. Okay, so now we can see the polarity is changed in this case. Okay, can you just show the before, one slide before? Can you just flash it? Previous slide. Okay, this is also fine. Okay, yeah. So you can see Q1 is a PNP transistor and Q4 is an NPN transistor. Therefore, in order to turn on PNP transistor, there should be a 0 and a low signal. And in order to turn on Q, likewise, in order to turn on Q2, that is NPN transistor, where you need a high signal, that is 1. And same case, for PNP transistor, you have to apply a low signal, or 0 is applied to the base of Q3. Okay, next slide, please. Next. Okay, you can see this diagram. Okay, how the polarity is changed. Okay, both the direction, as the direction changes, the motor's polarity gets reversed. Okay, I think with this diagram gives you some clear idea of the concept of edge bridge. Okay, if it's okay, we will move on to the next slide. Okay, so in order to control a single motor, we need two input signals. I have told you there are two different transistors should be turned on at a time. Okay, so if I give low, that is input 1 and input 2 is low, what happens? The motor will be turned off. And if it is 1, 0, the motor is turned on. If it is 0, 1, it has a moment of backward direction, and 1, 1, again the case is off. Okay, and can you just go to the 2 slides before, Rashid? One more, just one more slide. Okay, good. So see, if I short this Q1 and Q2 base of transistor, if I short this, okay, Q1, Q2 if I short the base, and Q3 and Q4, I'm shorting it with a wire, and it is to that place we are applying input 1 and input 2. Okay, if the input 1 is 0, that means Q1 and Q2 is 0. Input 2, that is Q3 and Q4. Okay, suppose I have shorted this wire, Q1 and Q2 and Q3 and Q4 being short. And input 1 refers to the signal that we are giving to the left side, that is Q1 and Q2, and input 2 refers to the signal that we are giving to Q3 and Q4. So if it is 0, 0, nothing happens. What happens? If it is 0, Q1 gets turned on and Q3 also gets on. So will that make the circuit complete? No. Since Q2 and Q3, so Q2 and Q4 are in off state, the circuit is not complete. And similarly, if I give both inputs, input 1 and input 2 in high signal, that is 1, Q1 remains turned on, sorry, turned off, because it's a PNP transistor, and Q3 is also off. And here you can see NPN transistor that gets on, and Q4 also gets turned on. Still, the case is the same. The motor circuit is not completed. The motor is in off state. If it is the case of 1, 0, take the case of 1, 0. 1, 0 means what? This Q2 gets on and Q3 gets turned on. So the circuit is complete and the motor moves in one direction. Take the opposite case, 0, 1. 0, 1 means what? PNP transistor Q1 is on and Q4 is on. Circuit is again completed on the through the left-sided path. Okay, I hope you're clear. And so shall we move on to the next slide? Next. Okay, this is what I was trying to tell you. If it is low, it's just can you just move on to the previous slide? Rashid, yeah. So this is what I was trying to tell you. If it is low, the motor remains off. If it is high, that is 1, 0, the motor moves in forward direction, and 0, 1, backward direction, 1, 1, and the motor will be in off state. This is the case of a single motor. In order to control a robot, we need minimum 2 motors and a caster wheel or a free wheel. Okay, like an auto rickshaw. You can think of that. So in order to control 2 motors, you may require minimum number of 4 input signals. That is, 2 input signals are required to control a single motor. So in the case of 2 motors, you may require 4 inputs. Okay, so next slide. Next slide, please. Okay, the one you can see on the left side is L298N motor driver. Okay, L298N motor driver. There you can see, I don't know whether it's visible to you. The one is, you can see the left and right, 2 blue color headers. You can see that. That will be the ones for connecting your motors. And there you can see input 1, input 2, input 3, input 4, where you should connect the input supplies, okay, or control signals. You have to connect to the input pins. You can see the 4 pins standing in the bottom. Okay, and there one other type of motor driver is L293D, and the other one is L298N. Both does the same function, controlling the polarity of the motor with both L293D or L. Motor or okay, Rashid, yeah. So in the case of wiper motor, I have shown you some of the motors before. That was BO motor, gear motor, and take the case of wiper motor where we have to hold some load, some medicines or water, food. There are situations when high current come, L298N or L293D may not be sufficient. It can get burned off. Okay, such cases, we make a split circuit with the help of relays. Okay, so here, if you know the working of relay have this is a 4-channel relay where it has got 4 input signals where you can control 4 relays separately. Okay, and I don't know, you can see this in 1, in 2, in 3, in 4 on the bottom, and just see if I give 0, 1. 0, 1 and 1, 0 is the only case where motor should be turned on. And for relays, there are 2 pins called normally open and normally closed pins. Okay, so suppose I'm connecting, if I give the input as 1, 0. Okay, let's see 1, 0, what happens. Then the first power line comes, relays are active low. So if it is a relay module, that will be working as active low. That is, whenever a 0 comes, the relay gets turned on. So 1, 0 is the case. So 1, 0, the relay is not on. The first relay is not on. Then what happens? It will be in the normally open state. Okay, normally open state, and it shall go to the motor 1 and come to relay 2, and the relay 2's common pin. And relay 2, there is 1 0. 0 means the relay is RA to C and motor 1. After that, it reached C. After that, it came to B, since it is the relay is turned on, and it is the connection is completed by making it to the ground. Okay, so just have the circuit and just have a wiring so that you can understand furthermore. Okay, if you are beginner, definitely go and start with a L293D or L298N. Okay, the next thing what we need is a microcontroller. Okay, we need a microcontroller to program these devices. Okay, this how to program these motors so that it moves forward, backward, left, right. So in the COVID-19, our objective is what we have to remotely control these devices. Okay, so that you can deploy Bluetooth, Wi-Fi, radio signals, whatever it is. Okay, so if you use Arduino, you can like interface a Bluetooth module and control the device or your robot with the help of your smartphone. And if it is an odd MCU, it has got built-in Wi-Fi, and you can control your robot with the Wi-Fi. And just see the circuit over here. As I have told you, we have since we have got 2 motors, we need 4 control pins. Okay, so that is the 4 control pins. You can see pink, blue, violet, orange lines. Okay, these are the control pins. So these pins will be responsible for controlling the movement of the 2 motors. Okay, so next slide, please. Okay. Okay, now you can see in L298N or L293D, we can see 2 pins called ENA or ENB. That is nothing else, enable motor A and enable motor B. Since there are 2 motors, we have got 2 enable pins. Third is that we can control the speed of the motor with help of PWM. If you don't use that also, there is no problem in that. Your motor is in constant speed. Okay, so you don't have to bother much about this enable pins. The only thing you have to worry about is your 4 control pins. Okay, and if you connect this this is a Bluetooth device, so module HC5. If you connect this to the 0 and 1 pin of the Arduino, you can establish a connection between this Arduino and Bluetooth. And next thing what you have to do is go and download a Bluetooth terminal app from your Play Store in your mobile phone, and you can control your robot or your motors by simply giving instructions from your smartphone. So this is the basic what till now we were discussing about the circuitry of the robots. The structure is always up to you. It is your creativity and your imagination that leads to the better structures. Okay, and I have showed you Nightingale 19. That is one simpler structure that some students have made. Okay, can you just show the pictures of the robots, Rashid? Just 2, 3, 4 or 5 slides back, I think. Rashid, can you hear? Yeah. So next slide, after the next slide, please. The one you showed was correct. Okay. 7th slide. Okay. So you just see the 1st, 2nd, and 4th. 7th slide is fine, Rashid. Yeah. Okay. You can see this. Everything, most of them working will be similar. Okay. and it all depends on the structure. Okay, uh, what we are dealing with is you have to deploy these our robots in the COVID-19 among the COVID-19 patients to help them, so that we can use what you can use a Bluetooth, Wi-Fi, or RF, any wireless medium for the communication to the robots. Okay, and the first figure, robot set of robots you can see, there's hand sanitizer, there's a glass, there's some bed sheets, and I think there is a tap where you can communicate. Like it has got some IP cameras, maybe you can like face-to-face interaction you can have with your medical staffs, all those things. And the second one is something used for sanitizing. So sanitization is done with the help of that robot, and you can it has got a tank and it sanitizes the area where it goes. And the fourth figure, and third one is something from abroad, and the fourth one is in startup mission. If you go and visit in Kochi, startup mission, you can see that robot over there. It's just it will give you instruction to sanitize your hand, and it has got a tray where some sanitizers are kept. Okay, so it will ask us to sanitize our hand frequently. Okay, when we enter their premises. Okay, so these are different types of robots which someone else have done, and now it's the time for people to imagine. It's your purely your imagination what leads to some new ideas. Okay, third one is from China, I guess. I just got from Google. The rest everything I know it's personally. And shall we move on to the next slide? I think our last slide. Rashid. Okay, Rashid. Before that, I have shared you with a code with you. Can you just share that too? I have shared a code.
Yeah, sure, sure. Wait a second.
Yeah. So that's if you have any question, just you can ask by the time Rashid gets the code. So I will give you a simple code, a shortcut where you can use that code to create your own robots. Okay. Just a simple Arduino code. Okay. I'm not going to embedded C or nothing. Just a simple Arduino code. I shall give you.
Guys, if you have any doubt, do put that in the chat box. We'll be addressing that.
So Rashid, it's an Arduino code. Is
Can you please guide me how to get it? Yes, is the link. Hello.
Sir, your mic is
Rashid, I shall share the text file then. Okay, just a minute. So, or can I share the screen? Just
uh,
can you make me the presenter so that I can share the screen?
yeah, sure, sir, 1 minute. Sir, can you share now?
I made you the presenter.
Okay, fine.
Should I try
Yeah,
sharing
I'm
now?
sharing it. Yeah, it's just getting ready. Just a minute. So can you see this code now?
Yes, sir, it's
Hello.
visible.
Okay. So others, this is simple C Arduino C code where I have defined 4 control pins to control 2 motors. So in A1, in A2, in A3, in A4. Okay, these are 4 pins which I am going to use it for controlling my 2 motors. That is a pair of motor I am going to control with the help of 4 pins. So in A1 means that is second pin of my Arduino. In A2 is my third pin of Arduino. In A3 is my fourth pin, and in A5 is my fifth pin. Okay, and coming to the setup function, there's something called serial.begin 9600. We just set up the baud rate, and we made every pins as output. Okay, and I have defined a variable such as it's called input. The what I'm going to do is if I give a signal or command W, yeah, okay, W means instead of that I shall change yes is backward. If I click B means backward. If it is F means forward. If it is A means left, and R means D means right side. Okay, so that is our objective. If I'm controlling my robot with the help of a laptop, so I'll be using. If I click F, it should move forward. If it is B, it should go backward. S, it should stop. Okay, L and right the same way. Okay, if you are using a Bluetooth module HC05, you can control the same with your smartphone. Okay, you can download a Bluetooth terminal app and give the same instructions. If you give F in your Bluetooth terminal, the robot shall go forward. Okay, so we are using a temporary variable to store our input command, what we are giving, or the instruction what we are giving to the robot. So I have used input character type and going to the loop, and input is X. Suppose I want X as by default, let it be X. Okay, so a random value so that no other garbage value comes into our variable. And see if serial dot available. Okay, available is a function which is used to see our serial monitor whether we are entering some instructions or not. If I enter anything, suppose if I enter F in my serial monitor of in my mobile Bluetooth terminal, this function, sorry, this if condition gets on or gets into the if condition, and input equal to serial dot read. To the variable input, what we have entered gets stored. Okay, so I just printed serial.println input, just printed onto the serial monitor. Okay, now I'm checking the condition. Okay, if input equal to B, that is, I'm just checking the equality condition of input with B. What the instruction what I given is B. What happens? This set of code, this piece of code gets executed. That is, in A1 is high, in A2 is low, in A3 is high, in A4 is low. That is what, if you remember the H-bridge concept or motor drivers, we had told if it's high low, it moves in one direction. If it is low high, another direction. So both the motors have to be moving in same direction. That is why in A1 and A2 I have given as high low. Similarly, 3, 4 as high low. So just print that serial print backward. This is not necessary actually. Just for your understanding, I have printed and I have given a small delay to what distance it should move. And just take the case else condition. If the inputs have stored the value of, if the input value is F, see the condition is just closed, that is forward condition, the low high. You can see in A1 is low, in A2 is high, in A3 is low, in A4 is high. That is low, high, low, high. Both the motors are moving in the opposite direction what we have given just before. Okay, that is forward direction. Earlier it was backward, now it is forward. And just give a delay to tell to how many distance it has to move forward. And next, take the case of left. If input is equal to L, I have told you in order to move to left side, what should we do? Turn on the left sided motor and turn off the left motor and turn on right motor. So that is the case. What is done over here? That is digital write in A1 low, in A2 low. That is the left side motor is off and right sided motor, see the case, low high. That is it moves or it is rotating. So that it turns. Okay, it turns to left. Now take the case of right side. In order to turn on to right side, here in A3 and A4 is my right-sided motor. That is I'm connected. I have connected A3 and A4 to my motor in the right side. So I have kept that motor off, and the left motor, see, I have given low high. It moves to the only left-sided motor gets on and moves to the right. Okay, go. You can see it stopped. In order to stop the motor, what should be done? Every pin has to be either high or low. Okay, here I have given in A1, A2, A3, A4 as low. So our robot or rover gets stopped. Okay, so this is the basic principle of using Arduino along with a motor driver. Okay, very simple. You can use that. Okay, so I just, for your information, I just shared this, and you can get the sample code, or I shall share this code with you if you need. Okay, so now it's time for you. If you have any doubts, you can ask. It's coding or whatever it is. Okay, I have shared this code with your panelists. You can get it from them if you need. Four motors with Arduino board. Definitely we can control 4 motor with Arduino board. So there are L293D or L298N is capable of controlling 2 motors. Only thing you have to use a different motor driver to control 4 motor. Okay, Gayatri, it's possible. Same thing. In order to control 4 motors, you may require 8 pins. Okay, same concept. The working, everything will be same. So others, get your doubts. I know this 1 hour is not at all sufficient to handle this topic. Others, please come on. I just love to clear your doubts. Come on. Hello. Come on, guys.
Guys, if you have any doubt, do put that in the chat box or let us know. We can unmute.
Guys, if you have any doubts in doubt session, chat session, you unmute your audio. You may just ask for them. Because we just got one doubt till now. It's from Gayatri. That is, can we control 4 motors with the ability?
I think it was answered already.
Maybe I didn't hear you.
We have only one
There was
doubt till now.
question.
Yeah,
think
that's
we
answered.
that.
Yeah.
Guys, if
Okay.
you have any doubt, do put that in the chat box or let us know. We can unmute you. So guys, I think there isn't any doubt. So can we conclude the session?
Is okay, there is one doubt. Is it possible to make small kind of robots without programming or coding? So, Joby, you can always start with this Arduino board. Okay, that's the most easiest way you can start. Like you can enter into the field of robotics. Okay, so it's very simple. That is, even a 10th or 7th standard students can do this. Okay, so it's not something very big. Okay, Arduino coding is very simple. You can do a lot of stuff with that. Okay, it costs only it's around 200 or 300 rupees for an Arduino board. Okay, so uh, it's always I prefer you can start with Arduino. Okay, and then what is the board normally used in drones? Drones, it's flight controls. It's not Arduino actually. We can do with Arduino. Just forgot the name. There is a board in drones, Gayatri. Just forgot its name. So I'll just Google it and tell you later. It's not actually Arduino. Okay, we can do, but in real drones or practical side, if you look, Arduino is not preferred. So that's why you are asking uh, for motors. Okay, in such cases, you need flight control boards. Okay.
Guys, is there any more doubt? If there is no doubt, can we conclude the session now?
Yeah. Okay, Gayatri, there is flight controllers. Okay, just see that. It's a simple board where all these things are done.
So I guess that's it. So thank you, sir. Thank you for your esteemed presence and thank you for sparing your precious time for us. We are always looking forward to working with you on more occasions. By the way, guys, the feedback form for the both sessions will be posted in the chat box. Do fill that. Tatu, could you please post that? So there will be a session by feedback for all the time. So don't forget to fill that. And now I invite Ashwini TS for the vote of thanks.
Hello, am I audible?
Yes, Ashwini, you're audible.
Okay, thank you. I feel honored and privileged to get an opportunity to deliver a vote of thanks on the fifth day of IFSFS 2020. On behalf of IEEE Young Professionals Area and the entire team, I convey my regards and hearty thanks to Mr. Verghese Benny for such an amazing workshop. In this current situation, application of autonomous robotics has paved a way for supporting many challenges. Thank you, sir, for such an extremely beneficial and thought-provoking session. Next, I would like to thank all the student ambassadors and young professionals for their amazing efforts in arranging the workshop. And at last but not the least, I would like to thank all the participants for joining us. Thank you everyone for making the event successful. Over to you, Deepika.
Thank you, Ashwini. So thank you, everyone. So just to know, tomorrow we will have the evaluation of the idea pitching on the problem and problem statement from 5 to 7 and a panel discussion on impact assessments on a sustainable humanitarian project from 7:30 to 8:30. So guys, that's all for today. Hope you had a great time. I'll see you tomorrow. Thank you, everyone.